Hello guys. Today we'll be learning Rust with me. I mean literally with me. This is the fifth stream of this series, and uh, previously we had covered control flow. No, not control flow. Sorry, comments and these functions. So we covered functions and comments. We covered these two. And, sorry, let me just bring up. Yes. So now we have control flow. Basically, the if else expressions and what else is there. If repetition with loops. Okay, and loops. Okay, so if L conditionals and loops. Okay, like loops have conditions, but well, I'm calling this if else. I'll just call it if else. So control flow, the ability to run some code depending on whether a condition is true and to run some code repeatedly while a condition is true are basic building blocks in most programming languages. The most common constructs that let you control the flow of execution of Rust code are if expressions and loops. Okay. Yep. So if expressions and loops. That's what we'll be covering today. If expression. An if expression allows you to branch your code depending on conditions. You provide a condition and then state. And this, if this condition is met, run this block of code. Okay. If the condition is not met, do not run this block of code. Okay. Create a new project called branches in your projects directory to explore the if expression. In the SRC main RS, you input the following. Okay, so this is like if else. So what we can do is, uh, okay. So what we are going to do is, just give me a second again. Where do I? Okay, just keep it here, नीचे. Uh, give me keep it here. Okay, fine. Okay. So yep. So what we are going to do right now, sorry, God, is this. I wanted to change this, and basically all I have to write is if else. Okay. So what we are going to do, uh, actually I'll do it first. So what we'll do is if else. Uh, yep. So there you go. Okay. How do I? Okay, just give me a second. Before I this Give me 1 second. Control, Control, Alt, Shift. Okay, wait, give me a second. अच्छा and drag that. No. Press Control twice and then without releasing it, press up and down arrow keys. Okay. Oh, nice, nice. Hmm. Okay, sorry for you know such a long pause. Uh, so basically, what I did. So if I undo it first. So what I was doing here before is match. I was pattern matching the guess number. Sorry. So I was matching guess number with the banner text. Okay. So pattern matching. So if I found it to be equal to uwin dot to string, then it would print, you know, the guess. It would print this guess num string, which we got from here. So we got a string from here, okay? And otherwise, so the problem was we didn't have a else case here. So basically ordering less than and ordering greater than. So these all actually got, you know, this is actually extra because we had to repeat code. So this was actually, unoptimized. So what I'm going to do is, well, can I do redo? I can't actually because I made another change. So I'll have to write everything again. चलेगा अभी के लिए. Okay. Okay, wait. Yep. So this goes. Forgot. Okay, you're back. So equals. So what we're going to do is turn this into an if else. We are going to put else. So we can just reduce this into two conditions like this. Okay. And then if this, and then this goes away. So basically what I did, there you go. So what we did is compare the guest number with the banner text, and um, there's a problem, I think. Okay, sorry. Okay, what I did is guest num equal to banner. So I compared if guest num is equal to banner text, basically the string we got from here, if this is equal to banner text, which was the win string, then I displayed the guest num or else continue. So for those of you who don't know, this program actually, you know, uh, the basic thing it does is basically it takes your user input and then it has a secret number which is generated at random. The user input is compared with the secret number, uh, and then on the basis of the value of the guess and the secret number, if the guess if the user input is less than the secret number, the random number, this will be returned too small. If it is greater than secret number, then too big will be returned. And if the guess number is equal to the secret number, then you win will be written. It will be assigned to this string. So this is an expression that we did. We covered it last stream. So what we'll do now is after this gets assigned, you're comparing it with the banner text over here. You win. So if this comes out, this will break. And the way it runs is until you guess the correct number, you won't be able to exit. The program won't stop running, basically, or until you just press the stop on this, your output. There's a stop button, just press stop. Uh, so you can do it like that also. But if else you have this, I think wasted a lot of time, but we'll move ahead. All if expressions start with the keyword if followed by a condition. So it starts by if, and this is the condition. If the string returned by the comparison is equal to you win. So this is the condition. Uh, in this case, the condition checks whether or not the variable number has a value less than 5. Okay. Yes. So see, this condition is basically if the number is. So what this program here did is it assigned 3 to a variable named number, then it said that if this number is less than 5, which it is obviously because it's 3, then it would print condition was true, else it would print condition was false. So basically, if you run this program, which actually we'll just cover, but I'll tell you, we place the block of code to execute if the condition is true immediately after the condition inside the curly brackets. This blocks of code associate with the conditions if expressions are some sorry. Let me just repeat this. Blocks of code associated with the conditions in if expressions is are sometimes called arms, just like the arms of in the match expressions that we just like the arms in match expressions that we discussed in comparing the guess to the secret number section of chapter 2. Optionally, we can also include an else condition, which we choose to do here, okay, to give the program an alternative block of code to execute should the condition evaluate to false. Okay, yes. Uh, so basically, the else is basically if this condition is not true, basically, which this will for example, if I change this to 6 instead of 3, then 6 is greater than 5. Or if I just change it to 5, only 5, because the condition is if number is less than 5, not less than or equal to 5. So 5 is equal to 5, which means it's not less than 5 in this logic and computer logic. So if you need, 5 to be accepted, then you have to put number is less than or equal to 5. Uh, so obviously, if you do like number now 6 or 5 is equal to 5, which is not less than 5, then this will print condition was false. So if you want to test it, we can actually do it. So I'm thinking that I'll actually create a new Rust file. Uh, like I did a lot of cancel. Well, I'll have to configure Git for this. I'll do it later. Then I'll actually push some code like learning wise. I'll also make it available in the future. Actually, in my Git repository, I have a Git repository. I have actually 2 accounts. I have two, so I've a couple of repositories with me. So basically, I'll share it on my GitHub that way. So what we are going to do here is we actually don't need to do anything. I'll just write it like this only because this is very short code. Right? If number is less than 5, yeah, so this will actually we'll just write this only basic code, which is basically this right here. Just to quote it. So if I run this, okay. So how do I? Give me a second here. Just actually, I want to make this run. I'll, so I built it. Okay, and I don't have to change anything in the Toml lock. Lock is lock actually. External libraries. There's src. How do I? I need to exclude it from. Okay, just give me a second here. Okay. Or I'll do one thing actually. There's something weird. I'll cut everything. And then we'll paste. And it will say two main functions. Cannot be more than one main function. But this main function is going to go here. There you go. Now we'll build exit code 0. Okay. So see, condition was true because 3 is less than 5. So now that it has executed, we'll try again with 5 only. Okay. Which I was saying. Because 5 is equal to 5, 5 is not less than 5. Condition was false. And if I put here less than equal to 5, now the condition will be true. So there's the difference between less than and less than equal to, which I think everybody know. Everybody knows. Sorry. So okay. So this was the if condition. You can also put extra conditions here, which I think this will cover actually right now. So we'll go here. So okay, else expression was done. Try running this code. Obviously, condition was true. Let's try changing the value of the number to a value that makes the condition false to see what happens. And run the program again. Condition was false. Basically, what this did. Uh, it's also worth noting that the condition in this code must be a bool. Okay, if the condition isn't a bool, we'll get an error. Okay. So if number, then okay, number was 3. No. So this won't work. Okay. Basically, it's saying like if I just remove the condition, actually the error will come right now. Just right now. Give me a second. Okay, it's not coming, huh? Let's see. Ah, yep. Expected bool found integer. Cool. So it has to be bool. But I'm confused actually. Normally it would, you know, the ID itself would actually warn me whether, say, so whether, if I'm actually putting in an integer instead of a bool because it's detecting the type here and, you know, like since the condition must always be bool, sorry. So since the condition must always be bool, then if it just detects an integer here, then it should throw and like it should show it in red, just like it did right now when I accidentally moved my mouse uh, the wrong place. And okay, the error, the if so okay, so try running the following code. The if condition evaluates to value of 3 this time and Rust throws an error. Okay, yes. Expected bool found integer. That's what we, encountered here. The error indicates that Rust has expected a bool but got an integer. Unlike languages such as Ruby and JavaScript, Rust will not automatically try to convert non-Boolean types to a Boolean, obviously. Okay. You must be explicit and always provide if with the Boolean as its condition. Okay. So this playing safe, Rust is playing safe with this. So it's like no, you have to put a boolean. You can't do like the other languages. You can't do it like the other languages. You can't just put if integer, something like that. Uh, it has its own shit running. So if we want the if code block to run only when a number is not equal to 0. For example, we can change the if expression to the following. Okay, if number is not equal to 0, yes, then number was something other than 0. Obviously, this would work because it's a condition. So, or I could also say, uh, did I press something? We'll just say not equal to 5. So, you're wrong. Okay, it's 5. So this is just an example. Okay, it's 5. Yes, sorry. Good. So there's a simple way to run this, but I just want to showcase this example to you. We'll run this. So it's not 5. Oh, oops, sorry. Yep, there we go. It's not 5. Obviously, it's not 5. And then if I just put 5 here, then it's 5. Yay. Okay. Um, so, hmm. So now that we are done here, uh, so now that we are done here, what we had to do was change this condition. Okay. Yeah, number now running this code will print number was something other than zero, obviously. So we did a similar thing here. Like I sometimes don't like to follow the the documentation as is, but instead I want to do it. I want to showcase the same thing in my own way, basically. So that's basically how I learn it. Um, then handling multiple conditions with else if, obviously. So now there would be more conditions. You could actually put as many conditions as you like using else if, but you need to have else, I think. If it is Rust, it might say you need else, but let's see. Because I think Rust is a bit, as much as my perspective is, on this thing, it's a bit safe. It plays safe, so it doesn't. It obviously it wants an else. I think. I don't know. We'll just go ahead with this. So you can use multiple conditions by combining if and else in an else if expression. For example, this program has four. Sorry, this file, whatever. So it is this basically divisibility condition. So do I'll actually, if you want me to do this exam, if I want to do this example, I can, but uh, we'll try something of our own. Okay, so let's say number is 5, and actually, we'll just do that divisibility. Wait, invalid left hand operand. It's still so what? Let's see. Oh, oh, AI. Ah, oh, okay. It needed that. Something there. Okay, no. We just do divisibility instead. I'll do something else. Let's say, if number What do I see? Could have just done the divisibility thingy, but I'm thinking of something else. And it becomes silent all of a sudden. Wait. Or nice. Nice. Yep. So we'll just do something like this. Okay. Right. Okay. Then 64 equal 1. And actually, we'll just keep doing this. Oh, sorry. Sorry. 9, 5. Uh, sorry. Blacked out. 16 bags. 9. Okay. Sorry. Yep. There we go. So I wrote this function here. This will do is if so it will basically check what number this is. But instead of the straightforward way of just writing if number is equal to 7, number equal to 5, I just did it in a different way. I just said it like if the square is you know if the square of the number is equal to 49. And yes, actually what we are going to do here is uh, are almost there. So six, one, one, three, 9, 8, 10. Huh. So I made this example a bit more realistic, since it is signed in teacher. So now we are talking. We could cover more numbers. It would be true anyways because the product of two negatives is a positive. So let's run this. So if I put 5, okay, it's 5 or minus 5, okay. And if I just put this instead, okay, minus 5. There you go. It's 5 or minus 5. So it won't matter. So if I just put 10 here, okay, minus 10, it's 10 or minus 10. Put 10 here, 10 or minus 10. And if I put this, it's not between minus 10 and 10, okay? Or if I just put an 11 here, yeah, it's not between. So basically what I did is, I compared the squares. So this, how I do my else. Sometimes I need to. So, you know, my 49 is the square of 7, 100 is the square of 10, 64 is the square of 8, 81 is the square of 9, 25 is the square of 5, 16 is the square of 4, 9 is the square of 3, 4 is the square of 2, and 1 is the square of 1, obviously. So, detecting numbers between minus 10 and plus 10. So this is, how I do, like how to do it, kind of. If in context of this, handling multiple if, section or the thing we are covering right now. The program has four, so this is actually a divisibility test. The code that is actually running right now. This not running right now. The code that is here. So this is the divisibility test. So this operation is basically the mod operation. Basically, what the mod operation is when you divide a number. So let's say number by 4. So if this is number divided by 4. So if the division does not leave a remainder, let's say if instead of 6, okay. So if I divide 6 by 4, okay, for example, the remainder will be 2, which means the number was not divisible. But if I just put 8 here, like 8 by 8 mod 4, so 8 divided by 4 is 2, but and there is no remainder. So 8 would, the if 8 is inserted here, this condition would print out. And see, since a number is divisible by 4, uh, here it is also divisible by 2. But like everybody knows that. And 6. So in this example, this would print number is divisible by 3 over here. When this program executes, it checks each if expression in turn. Obviously, it will check the top one first and then cascade down to the bottom ones. Okay. And executes the first body for which the condition evaluates to true. Okay. See, now even though 6 is divisible by 2, we don't see the output number is divisible by 2. Nor do we see number is not divisible by 4, 3 or 2. Text from the else block, obviously. That's because Rust only executes the block for the first true condition. And once it finds one, it doesn't even check the rest. I think this is synonymous with most programming languages, I think. Yep. Almost all of them, like C++, Java, Python, I think most of them do this only. The first condition it finds, it will straight up display an exit out of the, if else. Sorry. What's the time? It's 12:11, huh? So, okay. Using too many else if expressions can clutter your code. Okay. I know these are too many, but So if you have more than one, you might want to refactor your code. Chapter 6 describes a powerful Rust branching construct called match for these cases. Okay. So I understand. Using if in a let statement. Okay. Now this is the, you know. So because if is an expression, okay, so it's an expression, okay. We can use it on the right side of a let statement to assign the outcome to a variable, as in listing 3, 2. So, so what we are going to do here is, let me just, can we run else if also? I think we can. Okay, just give me a second here. Okay, so how do I replace Control R or Control? Wait. Let's see if this works. Okay, wait. In, oh, wait. No, actually, I had to do this. There you go. There you go. What's the error here exactly though? This? Oh yeah. Oh, because it's a statement. Yep. There you go. I was wondering what I missed over, and then I remembered I missed the semicolon. Like, guys, remember when you're programming in these kinds of languages, do not forget the semicolon. So, in this language, the semicolon is reserved for statements. So, this as a whole becomes a statement. Like, let guess str. This, sorry. अरे यार, give me a sec. So this whole thing, this is a statement uh, from let guess to this else, println guess star. So let's see. See, it's the same only. So number value is bound to a variable if based on the count outcome of the if expression. Run this code to see what happens. Value of number is 5. Okay. Remember that blocks of code evaluate to the last expression in them. Okay. And numbers by themselves are also expressions. Okay. In this case, the value of the whole if expression depends on which block of code executes. This means the values that have potential to be results from each arm of the if must be the same type. Okay. Yes. In listing 3 2, the results of both the if farm and the elf farm were I32 integers. So basically, that's why I put a toString over here instead of println. So because I have to put the result in a string, so I just put a toString in every output, whatever the program will output, like this. Yes, started. Okay. Uh, and just one more thing. Cool. So now quality wise might be a bit of a problem here. Right. This will keep turning off in a while. So bear with me here. Okay, so now we'll continue. What did we have to do? Okay, this keeps. So cargo run value. Remember that blocks of code. So we'll get a necker. Basically, that's why um, see, it's not between. Okay, just give me a second. Actually, my mic is not working properly. Okay, give me just a second here. Okay, so we are all set. I think mic is fixed. Let's see. Actually, there's a delay between here and the stream. So that's the only way I'll ever be able to find out. Uh, g- give me a second here. Cool. Uh, Now let me test the quality here. So okay. Let the quality is good now actually. Okay, so when we try to compile the code, we get an error. Obviously, we'll get an error if I put in anything else. If I just put in, give me a second here. Let's see. Okay. See, the error has already come here. Expected string, but found I32. So this was what I was expecting when, I did that Boolean prop thing, when I put number here instead of a condition. Last, last example. The expressions in the block evaluate to an integer, and the expression in the else block evaluates to a string. This won't work because variables must have single type, and Rust needs to know at compile time what type the number variable is. Definitely, definitively, sorry. Knowing the type of number lets the compiler verify the type is valid everywhere. We use number. Rust wouldn't be able to do that if the type of number was only determined at runtime. Okay. Yes, exactly. The compiler would be more complex and would make fewer guarantees about the code if it is hard to keep track of multiple hypothetical types of for any variable. Exactly. Something is wrong. So is it fine now? The audio is still choppy. Yep, audio is still choppy actually. Wait. No, it isn't fine. Just give me a second. Oh, it switched back. Okay, just give me a second here. Okay. Test, test. Sorry, yeah, this taking a lot of time, huh? It's going to be two by the time we are done at this pace. Just kidding. We'll continue. So, so basically, this is saying like that if it had to, track, multiple types in a single if condition, then it would actually have a hard time doing so. The compiler would be more complex. So now we'll go ahead with the repetition with loops. It's often useful to execute a block of code more than once. For this task, Rust provides several loops, which will run through the code inside the loop body to the end and then immediately back at the beginning. Okay. To experiment with loops, let's make a new project called Loops. Okay, but I'm not going to make a new project called Loops. I'll just write in main. Because creating a new project है bag, you don't have to create it again and again. So basically, we'll just make use of this. Okay. So there's something interference. Okay. So now what we have to do is Rust has three kinds of loops: loop, while, and for. Let's try each one. So loop was the thing we tried here. Okay, this loop. The loop repeating code with loop. The loop keyword tells Rust to execute a block of code over and over again forever or until you explicitly tell it to stop. Okay. As an example, change the src main rs file in your loops directory to look like this. Okay. Give me a second here. So we'll just make use of our old code. Okay. And over here, we are going to say okay. And so what we are going to do is we are going to put a loop over this code. Okay. And there you go. So what this program is going to do, so right now, okay, let me just do this. So what we are going to do here is we'll just change this. I'll copy this. We'll add use IO here. No, it will be used. Just wait. Uh, okay. Let and then we sorry let number and then over here there you go. Or if you want to, make it better, we'll just put number everywhere. There you go. So what this code does is we actually copied the input function from like the input code from the previous file. So we have a string. We read the string. We read the number. Okay. Then this. So then we have a number. So we then converted this number string to I32. Okay, so we converted it to I32 using parse. And if it is a I32 type, then it would it would assign the value of this number to number, or it would just say or if it isn't a integer, like if it isn't a number, then it would just loop back. And then if it is a number, then it would be compared over here. So if I just run this code quickly. So over here, 5, 4, 44. Oh, it's not. So just give me a second here. What I need to do here is print ln map. There you go. Now this program's better. Enter a number. So 2. Enters 2 twice. Okay. See? And then we'll just exit. So this is what this function does. This is a simple loop. When we run this program, so what happens here now? So when I pressed enter, empty here, When I pressed, I think enter somewhere I did. Yeah, here. So I just input a blank line, so it just looped back again. So this is the continue. So it skipped the rest of the part and then it went back to the starting of the loop. And here, then we have an if else. So basically, if I write anything between -10 and 10, it will keep looping on. If I write anything greater than 10 or less than -10, then it will break. It will come out of the loop. You know, since we wrote 65 here, it came out of the loop over here. And so this is the loop. So when we run this program, we'll see again printed all over and over continuously until we stop the program manually, like until you press the stop button here. Most terminals support the keyboard shortcut Control C, obviously, which I do it a lot. Control C to interrupt a program that is stuck in a continued loop. Give it a try. The symbol ~C represents the represents where you pressed Control C. You may not see the word again printed after the ~C depending on where the code was in the loop where it received the interrupt signal. Fortunately, Rust also provides a way to break out of a loop using code. You can place the break keyword within the loop to tell the program to stop executing the loop, just like we did here. Recall that we did this in the guessing game in the quitting after a correct guess of chapter 2, which we did actually a few streams back. Uh, where should okay to exit the program when sorry to exit the program when the user won the game by guessing the correct number. We also use continue in the guessing game, which in a loop tells me the program to skip over any remaining code in this iteration of the loop and go to the next iteration. Okay, returning. So we already did use continue over here. The, we used it here basically. Returning values from loops. Okay. One of the uses of a loop is to retry the operation know might fail, such as checking whether a thread has completed its job. Um, to do this, you can add the value you want to return after the break expression you used to stop the loop. Okay, that value will be returned out of the loop, so you can use it as shown here. Okay. So what we are going to do here is break. So I'll just add this as an extra example. Give me a second. Just let me check. Mic is still working. I was a bit scared about that. So let me continue here. Break number. Okay. Oh, okay. Sorry. Actually, wait. We can do this. end number. Oh wait, but this would be. Wait, would this even work? I'm I'm actually, quite amused right now. If I want to put my feeling in words, feelings in words. Um, what? Okay, so give me a second here. Okay. I could just say last number, but I'll just say end number. There you go. We'll do it now. Yep, it's working. Nice. This is nice. Okay. There you go. End number is now I'm so this also works. Like you can assign an entire loop, an entire piece of code to just one integer. Huh? Okay. Sorry. So, well, we returned a value. So basically, what this code did, let me explain. So what I did in this code is basically I assigned. So I assigned the number that would be, come in the else condition. So basically, if it's not between -10 and 10. So when the program breaks out of the loop, it will return this number 2, and this number would now be assigned to this end number right here. Sorry, this. That's why when I, you know, run this in the end, this println statement, the end number would come as this. This is also very clean if I'm looking at it. Wow. So you learn something new every day. Okay. Before the loop, we declared a variable name. So we actually basically did it, like this only. Okay. So before the loop, we declare a variable name counter and initialize it to 0. Then we declared a variable name result to hold the value returned from the loop. Obviously, on every iteration of the loop, we add 1 to the counter variable and then check whether the counter is equal to 10. If it is, we use a break keyword with the value counter plus 2. After the loop, we use a semicolon to end the statement that assigns the value to result. Finally, we print the value in result, which in which case is 20. So basically, what happens is we have a counter variable, and then in this loop, this gets incremented. Okay, this loop will run until counter is equal to 10. In this case, in which case it will break out of the loop and return this value, counter into 2, which is 10 into 2, 20. This value will be assigned to result, so that you could see the result in the output here. Okay. Loop labels should disambiguate between multiple loops. Okay, so we can do. If you have loops within loops, break can continue apply to the innermost loop at that point. Okay. Uh, Sorry. You can also optionally specify a loop label on a loop that you can then use with break or continue to specify that those keywords apply to the labeled loop instead of the innermost loop. Loop labels must begin with a single quote. Here's an example with two nested loops. Okay. So this is a loop. First loop is here counting up, and then there's a loop inside. So okay, so what this is I'll just explain it because actually I have fog, right? Oh no, actually I have two. So if I just do loop within a loop. So sorry, I'll just explain it. Uh, a count variable equal to 0 is declared. Then loop. Okay, just wait a minute. Should I just finish? I'll finish this explanation. Actually, I have some problem. I have to end the stream after just this explanation. Okay, I will actually cover the rest in the next stream, which should be tomorrow. Today in the evening or night. Sorry if like I'll have to cut this short, but. If you have loops within loops, break and continue apply to the innermost loop at this point. You can optionally specify loop label on a loop. You can then use with break or continue to specify these keywords apply to the label loop instead of the innermost loop. Okay, so sorry, or I'll do one thing. No, actually, we'll just have to end this stream. So count equal to 0 is assigned. Then the first loop executes. The value of count is printed. Then there is a new remaining. There's a new variable named remaining declared. So these both of these are mutable variables. Um, so remaining equal to 10. Remaining has the value 10. Then it would go into a loop. Then it would print the value of remaining equal to remaining. If remaining equal to 9, so if then it will break. If count is equal to 2, then so okay, if remaining is equal to 9, it will break this loop, this small loop. If count is equal to 2, it will break the above loop. So it will come out of the loop in total. And then remaining will be deducted if none of these conditions are true. And then count will actually increase after this loop ends. So I'll just run this program, okay? For now. So now that we can comment, we can just do this. There you go. There you go. So what we are going to do is just run this, and it should do this. So it would. So what happens is count gets increased by one after this loop. See, count is equal to 0, then it goes into the inner loop, remaining is 10. Then, you know, one is, so in the inner loop, then one is subtracted from 10. Then remaining equal to 9 is displayed, and since the remaining is equal to 9, it breaks. Okay. Then after that, count, the value of count is increased by 1. Okay. So now count becomes 1. Then this loop runs again. Then it would follow the same procedure until the count becomes 2. And then it will break out of the loop over here. Code prints this. So I'll actually end this stream right here. I have something urgent to do. I just remembered. And well, sorry for this early stream ending. It's still a lot of time actually. It's been more than an hour. So I'll continue this tomorrow night. Okay. Thank you for watching.